All right, so today we are in lesson 1-4 and we are learning all about absolute value functions. So, absolute values, as you guys should recall, are these guys right here with the vertical bars. And what an absolute value does is it takes whatever quantity is on the inside here and it spits out a positive number. So, what I want you guys to do for just a second on this first problem, you may remember how to solve these already, you may not. But it's not as simple as just, oh, get x by itself right now, because we've got these bars right here that are in the way. So, think about it. If I take the absolute value of something, so I don't even really know right now what the thing on the inside is equal to, got like a little question mark right there. But if I take the absolute value of something and it gets me the answer of 10, well, that means there are two numbers that could go on the inside of this absolute value. It could be that inside these bars is the number 10, because the absolute value of 10 does equal 10. It could also be that the thing underneath the bars or inside the bars right here is actually a negative 10, because if I had absolute value of negative 10, that would also get me out a positive 10. So, what you're supposed to do when you have an absolute value problem is break this problem up into the two scenarios. Either the thing on the inside is a 10, or the thing on the inside is a negative 10. Because we just discussed those are the two ways we could take the absolute value and get out a positive 10. So you guys probably remember this from Algebra 1. You are supposed to break it into two problems. Never change the inside. The inside stays the same for both. And the outside, you do 10 and you do negative 10 as well. And when you break it up, there shouldn't be bars written anymore. You just have two separate, easy problems to solve. So my first problem, I can just subtract 6. I get the answer x equals 4. And then my second problem, same deal. I subtract that 6 over. I'm going to get x equals negative 16. If you want to make sure these actually make sense, picture plugging in a 4 right here. 4 plus 6 is 10. Absolute value of 10, cool, does make 10. And then negative 16 over here, negative 16 plus 6 is a negative 10. Absolute value negative 10 is still positive 10. So it does actually work out. When you have a more complicated problem like number 2 right here, you're going to go ahead and get the absolute value by itself first. So you have to isolate the bars. I'm going to start by subtracting that 4 over. When I do that, I'm going to have a negative 12 on the other side. Now at this step right here, kids will sometimes want to distribute in that negative 3. You cannot distribute into an absolute value. What you need to do instead is cancel it out by dividing both sides by negative 3. So if you do that, now it's just going to say the x minus 2 right here in the absolute value equals a positive 4, and it's easy just like the last one. Never change the inside. So it's x minus 2 for both. You just do equals 4. And again, don't change the inside. You just equal it to a negative 4. And then we're solving both problems. So you're going to get x equals 6. And you're going to get x equals a negative 2 for your two solutions. Now, number 3 is a trickier problem that kids will get wrong a lot because they'll go in autopilot and they'll be like, oh yeah, branches, 2 problems, gotta solve. But if you think about what is happening here on this third example, we are taking the absolute value of something and we're getting the answer of negative 3. If you take an absolute value on something, you can never get out a negative answer. That doesn't make any sense at all. So if you see an absolute value by itself and it equals a negative number, what you're supposed to do is just shut things down. It is a no solution. This problem doesn't make sense. Absolute values cannot equal negative numbers. And write that as a little note for yourself. Absolute values can't equal a negative. On my last problem, if you guys look back at number 2, I did have a negative right here. I had a negative 8 and then negative 12. But when I isolated the absolute value, it ended up being okay, where I got out a positive number. So that's a nice little review of stuff you guys talked about in Algebra 1. What I want to do today for the second half of this video is establish a new kind of graph for you guys, an absolute value graph. And we are going to start by looking at the graph of y equals the absolute value of x. Algebra 2 is all about the study of new kinds of equations and new kinds of graphs. So this right here, absolute value, makes a different shape than like a regular line does. And this is actually our first new example of what's called a parent function. Parent function is a new vocab concept right here. A parent function is like the most basic version of a graph that's possible. If I was going to graph an absolute value, it doesn't get any more basic than just straight up absolute value of x. What we'll start doing later on is we'll graph things with subtraction and with numbers in front like this that are more complicated, adding a number right here. But this is a more complicated version of this. You guys might have seen a different parent function. We've talked about in Algebra 1, we would have done y equals x squared. That's another parent function that we'll talk about next chapter. But we're just going to analyze how you would graph the absolute value of x. And we can't just go using a little shortcut like, oh yeah, y equals mx plus b, because this isn't a linear graph. Anytime we are graphing something new, what we're going to end up doing is making a table. So this is a big theme in Algebra 2 that we keep coming back to. When we want to graph a new kind of equation, we always start by making a table. Once we figure out what's going on in the table, we can analyze it and we can basically find shortcuts later on. And what I'm going to do is start by just plugging in some x's. I can plug in whatever x's I feel like here, but I'm going to start with just nice, easy, basic numbers because who wants to graph some gross thing like 1,000s? If I plug a 0 in for x to this equation, the absolute value of 0 is 0. So the point 0, 0 is on this graph, and I can put a dot right there. If I plug in a 1, absolute value of 1 is 1. So 1, 1 is on this graph. If I plug in a 2, absolute value of 2 is 2, and so on, and so on, and so on. So it's looking an awful lot like a linear graph right here. In fact, I could sit here for literally the rest of my life, plugging in 4, 5, 5.2, 5.3, 6, 7, 8, 9, and so on, and I would live my whole life thinking this was a linear graph. The thing that makes this different, though, I didn't plug in any negative numbers. If I plug in a negative 1, the absolute value of negative 1 is actually a positive 1. Spits out a positive number. So the point negative 1, positive 1 is going to be on this graph. Negative 2. If I plug in a negative 2, I'm going to get out a positive 2. If I plug in negative 3, I'm going to get out a positive 3, etc., etc., etc. So what you end up seeing for this graph, it's not just a line. You actually get, when you graph an absolute value, a V-shaped graph. Both sides are straight, linear, but they're going in different directions right here in a V shape. That is something that is really important for you guys to remember. Absolute value graphs make a V. And that will be true of every single absolute value graph we do in Algebra 2. You could get really crazy and do fancy like things beyond Algebra 2, and maybe you'll see other shapes. But your basic absolute value graph, absolute value of x, make a V shape. So maybe I'm going to add, just to be like super thorough here, absolute value graphs of x make a V. And that's all I will ever do with you guys in Algebra 2. So if you see absolute value, you should know that you're going to see a V for your basic graph. I want to close out this video by talking about a couple features of graphs that I will make you do again and again. Some of this will look familiar to you guys, and some of it's going to be new for Algebra 2. The first thing I want to always ask you for when we do absolute value graphs is the vertex of your graph. The vertex, you guys might remember from Algebra 1, we talked about it with parabolas there. It's going to be this point right here where the absolute value changes direction. It's going one way and then it bounces and goes the other way right here. The vertex of this graph occurs at the point 0, 0. Something else I will frequently ask you for is called the axis of symmetry. You guys can see that my V-shaped graph right here is actually going to be a mirror image of itself on both sides. If I were to draw like a dashed line right here, this line makes it so the graph is symmetric on both sides, mirror image both sides of that line. When you do an axis of symmetry, you're going to talk about its equation. It's a vertical line right here. Vertical lines are x equals. Kids will forget to write x equals sometimes. And this occurs at x equals 0. The axis of symmetry will always share the x value from your vertex right there. The last two things that I'm going to ask you for with absolute value graphs are the domain and the range. And this should be a relatively new concept here for you guys in Algebra 2. So, domain and range. We talked earlier in this chapter about how domain is x's and range is y's. Let's look at what x's this graph is going to use. We've already seen, based on my tick marks here, that's 0, 1, 2, 3, 2.6, 3.14, 3.98, stuff like that. Those x's are all tick marks that I need to have because I can put a dot at those values. So all the x values that line up with these points right here are x's that I use. If I got all the way over here to 10 on x, well, shoot, I can plug in a 10 and get out a 10. So 10 comma 10 is on the graph. If I wanted the x of 11 or of 47 or of 99999, basically as this graph keeps going this way, it's going to keep on going to the right, and it's eventually going to get to every single x value on this picture. The same thing's going to happen on the left side of this picture. -3, -4, -5, -90, -1000, -1,000,000. All of those x's are going to get used on my picture. Every single x will eventually get hit on the tick marks right here. And if it's every single x, we call that all real numbers. All real numbers is the domain of this graph because every x will eventually get hit to the left and to the right. On the other hand, my y values for this picture are not going to have a range of all real numbers. These y marks right here, +1, +2, +3, +4, +1,000, all of those tick marks are going to get used. But look at the tick mark -1 or -2 or -3. Because the graph is angled upwards right here, it will never, ever, ever use y tick marks down here. So those tick marks don't matter for my y. The y's that I actually use start at 0 and they go higher than 0. So I'm going to put for my range, y is greater than or equal to 0. The y's on this picture are from 0 and above. We will practice this some more in the second part of the video, but practicing domain and range is important, and it's not that bad once you learn how it works.